These are the solutions for practice for section 3B. So practice 3B solutions. Okay, so the first question, you're given a linear equation, right? So 4x plus 3y is equal to 28. And you're asked to find the slope and the y-intercept. So the way to do that, right now this linear equation is in standard form, right? Remember ax plus by plus, or ax plus by equals c is standard form. But we want to write it in slope-intercept form so that we can easily pick out the slope and then pick out the b, which will lead to the y-intercept. So what does that mean? It means we have to solve this equation for y. And if we do that, it'll be in slope-intercept form. So how do we solve this for y? So this goes back to chapter 2, basically. We need to isolate the y. So first thing, right, we want to keep the 3y. We want to remove the 4x, get rid of this on the left-hand side. So if we subtract 4x, that'll be 0 on the left-hand side, but whatever I do to the left-hand side, I have to do to the right-hand side. So now I have 3y is equal to, and I'll write this as negative 4x plus 28. Okay, I'll move this up a little bit. So now how do we get y by itself? Well, I need to divide both sides by 3. So at this point, I will divide by 3, divide by 3. So then I have y is equal to, well, you can write this, you can break this up into negative 4x over 3 plus 28 over 3. But that's the same as y equals negative 4/3 times x plus 28/3. Okay, why is this useful? Because now it's in the slope-intercept form, and we can easily pick out the slope in the y-intercept, right? So in this case, remember the slope-intercept form is y is equal to mx plus b. So the m is the coefficient of the x term, so that must be negative 4/3. And then the b, which is basically the y coordinate of the y-intercept, that's got to be the 28/3, right? So in this case, the slope is equal to negative 4/3. And then the y-intercept, remember it's always written as a point, it's 0 comma b, so it's 0 comma 28/3. So in this case, the answer should be A. Okay, next question. So question 2 is write the equation in slope-intercept form. Okay, so we're given 6x minus 4y is equal to 3. So I want to write this in slope-intercept form just so I don't have to worry about dividing by a negative value at the end and distributing that in. I'm going to bring the 4y, the negative 4y to the right-hand side. So I'm going to do that by adding 4y. You don't have to do this. You could leave it on the left-hand side, but I think it'll be easier just to keep that coefficient of the y positive. So I'm going to add 4y to both sides. So I have 6x is equal to 4y plus 3. And now I need to get rid of that 3, right? So if I subtract 3 from both sides, that'll give me 0. And then I also need to subtract it on the left-hand side. So at this point, I will have 6x minus 3 is equal to 4y. And then finally, I can divide both sides by 4. Okay, so and then I'm going to write the y on the left-hand side now. So I have y is equal to 6x over 4 minus 3 over 4. And then 6/4 can be simplified to, well, 2 goes into 6 3 times, 2 goes into 4 2 times, so this is 3 halves x minus 3/4. So that is the slope-intercept form, right? It's in the form y equals mx plus b. So the correct answer in this case would be C. So that's going to be C. Okay, so question 3. I'll go do a new page here. So question 3 is y minus 1 equals 2 times x plus 10. And again, I want to write it in slope-intercept form. So the first thing I need to do is I need to distribute in that 2, right? I need to multiply in the 2. So if I do that, right, remember it multiplies by both terms. 2 times x is 2x. 2 times 10 is positive 20. And now if you think about it, right, I need to do just one more thing. I need to isolate the y, so I just need to add 1, right, get rid of that negative 1. So if I add 1 to both sides, then I'll have my answer. So y is equal to 2x plus 21. So now it's in the slope-intercept form, right? It's in the y equals mx plus b form. So that should be, again, C is the answer. Okay, 4. Find an equation in slope-intercept form of the line satisfying the specific conditions. So in this case, the line has to pass through the point -4, 3 and be parallel to the given line, which is 6x plus 5y is equal to -49. Okay, so it has to pass through that point and be parallel to that given line. All right, so remember, whenever we're trying to find the equation of a line in slope-intercept form, we need to figure out the slope and we need to figure out the y-intercept. If we want our new line to be parallel to that given line, then we want our slope to be equal to the slope of that given line. So the first thing I would do is I would find the slope of that given line. So we need to rewrite that equation in y equals mx plus b in slope-intercept form, and then we can pick out the slope. All right, so let's do that first. So I'm going to solve this equation for y. I'll write it down one more time here. Okay, so I need to subtract 6x from both sides. So I have 5y is equal to -6x minus 49. And then I need to divide by 5. So y is going to be, well, I can write this as -6 fifths x minus 49 fifths. So the slope of this given line is -6 fifths. Okay? So that means if we want our line to be parallel to that given line, then we want exactly the same slope, right? So for our line, I'll call this, I'll call it M nu, meaning our line. Since it's parallel, we want our slope to be equal to -6 fifths. Okay? And we want it to, again, what was it? Passing through -4, 3. Right? So passing through -4, 3. Okay, so you're going to get this situation many times, right? Where you know the slope and you know a point that the line passes through, and you're asked to find the equation of the line. So the way you do that is you write it in y equals mx plus b form. So I'll just start with that in general, y equals mx plus b. And then we can plug in the slope because we know that slope has to be -6 fifths. Okay, so I have -6 fifths x plus b. And then how do we find b? Well, if that point, the -4, 3, satisfies the equation but lies on the line, then I can plug in that point, right? I can plug in x is -4, y is 3, and I can solve the equation for b. So that's the general step that you'll always do. You'll plug in the given point that the line passes through and use that to find b. So in this case, right, the x is -4, the y is 3. So if I plug in 3 for y, and then -4 for x, I can solve this for b. Now, it's a little bit of work because it's fractions, but we'll work through this. So we have 3 equals, and remember, I'll do this on the side over here. Remember, -6 fifths times -4. You can think of it as -4 over 1. This is going to be 24 fifths. Okay, so this is 24 fifths plus b. And then there's a bunch of different ways we can solve this for b. We could just subtract 24 fifths from both sides. You could do that. Or we could clear out fractions by multiplying everything by 5, right? Actually, let's use that second method. I'll clear fractions by multiplying both sides by 5. So I have 5 times 3, and then 5 times the entire right-hand side. Okay, so 5 times 3 is 15. And if I distribute the 5, well, 5 times 24 fifths. Here, I'll do it up here again. Remember what that means. This is like 5 over 1 times 24 over 5. So the 5s cancel, right? And you 1 and 1. You're just going to get 24. So this is 24 plus, and then 5 times b is 5b. And now it's pretty straightforward to find b. I need to subtract 24 from both sides. So what's 15 minus 24? Well, that's a -9, right? And that equals 5b. And then finally, I can divide both sides by 5. That'll cancel. So b is equal to -9 fifths. So therefore, the equation of the line that meets all those criteria, right, that's parallel to that given line and passes through that point, -4, 3, is going to be this equation. It's going to be y is equal to -6 fifths. That was our slope, x. And now we know b is -9 fifths. So plus the -9 fifths is the same as -9 fifths. So that's our answer. So it looks like it should be A in this case. Okay, number 5 is we want to find the equation of the line that passes through the point -3, -8, and it's perpendicular. I'll use that symbol to mean perpendicular to this equation, -9x plus 8y equals -21, right? So it's perpendicular to that particular given line. Okay, so again, we want to first find the slope of the given line. So to do that, I'm going to solve that equation for y. Put it in y equals mx plus b form. Okay, so to do that, I need to add 9x to both sides. So I have 8y is equal to 9x minus 21. And then finally, I need to divide by 8. So y is going to be equal to 9 over 8x, right? 9/8 x minus 21 over 8. So the slope of the given line is 9/8. And then since my line is to be perpendicular to that line, remember what the rule is, right? The slope of my new line, I'll call it m new, is going to be -1 over the slope of the given line, right? Because if I multiply the two slopes together, I have to get -1 to be perpendicular. So if I solve for one of those slopes, say m new, it's going to be -1 over the given slope. Well, okay, that's no problem. And so let's do that right now. So I have -1, I'll write this as -1 over 1 divided by 9/8. But that's the same as -1 over 1 times the reciprocal, right? I need to flip the bottom one. So this is -8/9. The quick way to do it is just flip it and put a negative. Okay, flip the value of the slope from the given line and put a negative in there, and that's got to be the slope of the perpendicular line. So we want our line to have a slope of -8/9. Okay, so now I know my slope, so I can plug that in. So now in the equation, y equals mx plus b, I can plug in -8/9 x plus b. Okay. So again, how are we going to find b? Well, we have an additional piece of information. We know that the line, our new line, has to pass through the point -3, -8. So if I plug in -3, -8, it has to satisfy that equation, and that will allow me to find b. Okay, so remember, this is always x, y. So let's plug that in. So I have -8 is equal to -8/9 times -3 plus b. So again, a little bit of work because we have fractions, but we can handle this. Okay, so we have -8 is equal to, I'll do this on the side, -8/9 times -3 over 1. Well, let's simplify this a little bit, right? So 3 goes into 3 once, 3 goes into 9 3 times. So we have -8 times -1 is 8 over 3 plus b. And then just like before, to solve for b, it might be easier just to clear out fractions. So let's do that. And how do we do that again? We multiply both sides by the lowest common denominator, which in this case is 3. So I'll multiply left side by 3 and the right side by 3. Okay, so 3 times -8 is -24. Then if I distribute in the 3 here, well, 3 times 8/3 is going to be 8, right? Again, I'll do it on the side. 3 over 1 times 8 over 3. So the 3's cancel, and I just get 8 over 1, which is 8. And then 3 times b is 3b. And now if I subtract 8 from both sides, well, -24 minus 8 is -32? And that's equal to 3b. And then if I divide both sides by 3, right, I'll find that b is -32/3. Okay, great. So now we have everything we need, right? We know the slope was -8/9. So I can plug into the y equals mx plus b formula now. Right, we already had m anyways. We were just solving for b. So let's finish this. So y equals -8/9 x, and then plus a -32/3 is the same as -32/3. So it looks like, let's see, in this case, it looks like B is the correct answer. So it should be B. Okay, question 6. We want to find the equation of the line that passes through the points 2, -16, and -1, -4. So to do that, again, we need to find the slope, and then we need to find b, right? So let's calculate the slope first. So label these. Remember the first point that you see, the first ordered pair, just call the 1. So I'll call this x1, y1, and the second one I'll call the 2s, x2, y2. So then the slope is always y2 minus y1 over x2 minus x1. So in this case, it would be -4 minus a -16 over -1 minus 2. Okay, so -4 minus a -16 is the same as -4 plus 16, which is a +12. And then -1 minus 2 is -3. 12 divided by -3 is -4. So we know our slope is -4. So in terms of the equation, it's going to be y is equal to m, which we already know. So I'll plug it in, -4x plus b. Okay, so how do we find b in this case? Well, we plug in one of our points. And it doesn't matter which point that we use, right? They will both satisfy the line. Either point will give you the correct answer for b. So let's just pick, it doesn't matter. Let me just pick the first one. So for y, I'll plug in -16. For x, I'll plug in 2. So I have -16 equals -8 plus b. And if I add 8 to both sides, then I get -8 is equal to b, right? So b is -8. So the equation of the line must be y is equal to -4x minus 8. So in this case, number 6, it should be D. D is the correct answer. Okay, 7. We want to find a horizontal line that passes through the point -2, 2. Okay, so remember, here we can even plot this out. So here's my Cartesian coordinate system. Right, x, y. So the point -2, 2 means start at the origin, move 2 to the left, and then up 2. So that's right there. And then the line is the horizontal line that goes through that, so it's going to look like this. Okay. So this is one of our special cases, right? Remember, a horizontal line and vertical lines are special cases. In a horizontal line, remember, had the formula y equals a constant. We usually call that constant b. Right? It's what the y coordinate is always going to be of all the points that lie in that horizontal line. So in this case, I mean, you can see it easily from the given point, right? It must be 2, right? Y equals 2, because it's saying that all these points right here have the coordinates something comma 2, something comma 2, something comma 2. So the equation, the correct answer is going to be y is equal to +2. So that should be B in this case. Okay, 8. All right, find the equation of the graph. And actually, the easiest way to do this, if you notice, right, if you look carefully at that graph, it's going through the points -2, 0. And it's also passing through the point 0, 3. Right, so this becomes a problem just like the one we just solved. We need to find the slope first. So if I label this x1, y1, x2, y2, then this is going to be y2 minus y1 over x2 minus x1. So 3 minus 0 is 3. And then 0 minus a negative 2 is positive 2. So it looks like the slope is 3 halves. Okay, so the equation is going to be y equals 3 halves x plus b. Actually, let me fix that. Hold on. Plus b. So how do I find b? Well, I can plug in either point, but the easiest point to plug in, right, is when x is 0. In fact, we already know that this 3 right here must be our b, right? Because 0 comma b is the y-intercept. It has that form. So, but here, let's plug it in to show you that. So if y is 3 and x is 0, then I have 3 is equal to, well, 3 halves times 0 is just 0, right? Plus b. So this is saying that b is equal to 3, right? And we already knew that because if you have a point that's 0 comma something, that b is the y coordinate of that point. So the actual equation now is going to be y is equal to 3 halves x plus 3. So that would be the equation of that line for number 8. So let's see, it should be C is the correct answer. Okay, number 9, we're given an inequality in 2 variables, right, in x and y. So x plus 2y is greater than negative 3. And we want to figure out whether this point, 3, negative 1, is a solution to that inequality. In other words, does it lie in a shaded region? Remember when we plot these inequalities, we're going to get like a half shaded plane. So we want to know whether that point lies in the shaded region. So the easiest way to figure this out is just plug it in, right? Plug it in and see if we get a true statement or a false statement. If it's true, then it is a solution. If it's false, then it's not a solution. So we're going to plug this point in. So where I have an x, I want to plug in a 3. And where I have a y, I'm going to plug in a negative 1. I'll put a question mark here. So 3 plus, well, let me multiply 2 times negative 1 first, so that's negative 2. So 3 plus negative 2 is 1. Is 1 greater than negative 3? Yeah, that's true, right? 1 lies to the right of negative 3 on a real number line, so this is true. So is the point 3, negative 1 a solution to that inequality? Yes. Yes, it is a solution. So the answer would be A in this case. Okay. Now we want to actually graph the inequality. So number 10. We're given the inequality 2x plus y is less than or equal to 3. And we want to graph that inequality. Okay? Let me make a Cartesian coordinate system over here somewhere. So x, y. And remember how to do this, right? There's several different steps for doing this. The first step was in place of the inequality, make it like an equal sign. Put an equal sign in there, and it becomes a line, and we want to graph that line first. Okay, so I have 2x plus y equals 3, right? That's the corresponding line. I want to graph that corresponding line first. How do we do that? Well, we can make a little table. And we'll just pick some easy values to plug in. So x, let's say x is 0, right? That's easy to plug in. So we have 2 times 0 plus y is equal to 3. Well, the 2 times 0 is just 0, so this is just y is equal to 3. So when x is 0, y is 3. And then maybe, I don't know, maybe x is 1 would be easy. You could also do the we just did the y-intercept, right? 0, 3. You could also do the x-intercept, but then you're going to get a fraction. So let me try 1 for x. So I have 2 times 1 plus y is equal to 3. So 2 plus y is equal to 3. And if I subtract 2, I'm going to get y is equal to positive 1. So 1, 1 is also a point on that line. Okay, so now let me graph this line. Now, remember, if we have this situation where it's less than or equal to, right? If it includes the equal to, then we have to graph this line as a solid line. If it was strictly less than or strictly greater than with no equals, then you'd graph it as a dashed line. So in this case, it's going to be a solid line. So first thing, let me find the point. So 0, 3, and 1, 1. So 0, 3 is right there, and then 1, 1 is right here. So it looks like this line is going to look like this. Something like that. And then how do we figure out what side to shade? Well, remember, in that case, we have to pick a test point. So that's any point that doesn't lie in a line. You can choose anything you want. But it's probably easiest if we choose 0, 0, if it's available, right? So let's choose 0, 0, just because it's easy to plug in zeros. And now we plug that back in. So let me go back over here. We plug that back into the inequality. So I have 2 times 0 plus 0, right? X is 0, y is 0, is less than or equal to 3. Well, 2 times 0, 0, plus 0 is 0, is less than or equal to 3. Is that true or false? Well, in this case, that is true, right? This is true. So therefore, the side that I picked a test point on should be shaded, right? Because it's in the solution region. So this is the side that should be shaded. The side containing that test point. Okay? So in this case, it looks like the answer is going to be D. So D should be the answer. All right, number 11. Okay, so same sort of question. I want to graph this inequality. X plus 4y is greater than or equal to 5. Okay, so I'll make some room over here. Oops. So let me do a Cartesian coordinate system over here. So x, y, and let me go back. Okay, so remember our first step, make the inequality an equal. So I have x plus 4y equals 5. And I want to graph that line. Okay, so I'll make a little table. You should try to pick nice, easy values that work here. So it looks like, can you guys see if I choose y as 0, then that just leaves x as 5, right? So that would be the x-intercept. So let me do that out for you. So I have x plus, I'm choosing 0 for y. So that term is going to be gone, and I'm left with x is equal to 5. So that was a nice, easy point. And then maybe, let's say y is 1. I choose y as 1. Then I have x plus 4 times 1 is equal to 5. So x plus 4 is equal to 5. And if I subtract 4, I'm going to get x is equal to 1 as well. So 1, 1 is also a point. You can choose anything you want. We just want to try to avoid fractions because it's hard to plot fractions on, especially if we're doing it by hand on a graph. Okay, so 5, 0, and 1, 1 are the 2 points. So let me bring this back to the graph and then plot those 2 points. So 5, 0 means move to the right 5 and up nothing, so right on the x-axis. And then 1, 1 is this point right here. So the line is going to look something like this. It's going to pass through those 2 points. Okay, now we need to choose a test point. So again, you can use any point you want, right? It doesn't lie on a line. I could use like 10, 10 or whatever I want. But if it's available, I would just choose 0, 0 because it's so easy to plug in 0. So we're going to test 0, 0 again, okay? So I go back to inequality now. And where I have an x, I plug in 0. Where I have a y, I plug in 0. And this is now greater than or equal to 5. So this is 0 is greater than or equal to 5. Is that true or false? Well, 0 is not greater than or equal to 5, right? It's less than 5. So this is false. So what side do I shade? I shade the opposite side of the test point. So in this case, this would be the side that gets shaded, right above. So for this example, the answer should be A. Is the correct answer. Okay, number 12. We want to graph this inequality. 2x plus 3y is greater than or equal to negative 6. Okay, so again, let me draw out my Cartesian coordinate system. So x, y. And same steps, right? So first step, make the inequality symbol an equals sign. So graph this corresponding equation. So I'll make a little table. In this case, it's probably easier to use the intercepts, right? So if I make x 0, that first term is gone. And now I just have 3y equals negative 6. So if I divide by 3, y is going to be negative 2. And then if I make y 0, right, the second term is gone. So 2x plus 3 times 0 is equal to negative 6. So that gives me 2x is equal to negative 6. And now if I divide by 2, I have x is equal to negative 3. Okay, so I can plot those 2 points, 0, negative 2, and negative 3, 0. So 0, negative 2 is right here, and then negative 3, 0 is here. So this line is going to look like this. Okay, choose a test point. Again, it's available. Let's use it because it's easy to plug in. I'll plug in 0, 0. So if I go back to the inequality, now I have 2 times 0 plus 3 times 0 is greater than or equal to negative 6. Well, the left-hand side is just 0, right? 0 is greater than or equal to negative 6. That's true. Right? 0 is greater than negative 6, so that's true. So therefore, the side that I chose that test point is what is going to get shaded. So this should get shaded. So any point in here, right, is going to be a solution. Okay, so in terms of the correct letter of the answer, it should be A, I guess. Yeah, A. Okay, 13. So again, graph this linear inequality. So here's my Cartesian coordinate system. X, Y. Okay, make the inequality an equal sign. So I have X equals 2. And make a little table. But you should recognize that this is one of our special lines, right? Remember, whenever you have X equals a constant, that's going to be a vertical line. If you want, you can put it in the standard form, AX plus by is equal to c. So in this case, it'd be 1 times x, right? X plus b is 0, right? 0 times y is equal to 2. So if I make a little table, it doesn't matter what I plug in for y. Y can be anything. So I'm just going to pick a few values. But the x, when I solve for x, it's always going to be 2. Right? It doesn't matter what I put in for y. X is always 2. So when I graph this line, right, let me plot those points. So I have 2, negative 2 is here. 2, negative 1 is here. 2, 0 is here. 2, 1, 2, 2. So if I graph that line and pass through all those points, it's going to be a vertical line. Remember? So that's, again, one of our special cases. So if the equation is x equals a constant, it's always going to be a vertical line. And I draw it solid because it's greater than or equal to. Right? So it's solid. All right, but now the rest of it is the same. I choose a test point. Since 0, 0 is available, let's use that point. So 0, 0. So if I plugged it in, well, there's no y. I don't have to worry about y. So x is 0 is greater than or equal to 2. Is that true or false? That's false, right, in this case? 0 is not greater than or equal to 2. So that's false. So therefore, what side do I shade? I shade the side opposite the test point. So everything all the way to positive infinity, everything past through to positive infinity, including the line, is going to be part of the solution. So in this example, it looks like it's going to be B. Would be the correct solution. Okay, and then the last one, actually, let me do a new page for the last one. Okay, so the last one, question 14. It says a hardware store has room for 1,000 bags of fertilizer. The fertilizer manufacturer plans to ship X bags of fertilizer with weed killer and Y bags of fertilizer without weed killer. This can be represented by this inequality. So let me write that down. So X plus Y is less than or equal to 1,000. And we want to graph that inequality. Okay, so it's going to be the same sort of steps that we've been doing. So let me draw a coordinate system first. So something like that. I'm not going to put tick marks yet because they're going to be much larger. You'll see in a second why. So let me go back to the inequality. Remember, the first step is change the less than or equal to an equals. So the inequality to an equals. And I need to graph that line, right? So that's my line. I want to graph it. So if I make a little table here, well, again, the easiest values to use are the intercepts, right? So if I force x to be 0, what is y? Well, y's got to be 1,000. And then if I make y 0, what's x? Well, x must be 1,000. Right? So if I plot those points, 0, 1,000 is, say, right here. This is 0, 1,000. And then let's say 1,000 is right here. So the line that passes through those points is going to be this line. And since it's less than or equal to, I'll draw it as a solid line, right? So this is a solid line that goes through those 2 points. Okay, just like before, I need to choose a test point. So since it's available, let's just use 0, 0 again. So this is 0, 0. So if I plug that into the inequality, I have 0 plus 0 is less than or equal to 1,000. Well, that says 0 is less than or equal to 1,000. That's certainly true, right? So I know that everything on the side that the test point on gets shaded. But here you have to be a little careful. Because this is a real world problem where x, so this is, remember this is x and then this is y. The x represents bags of fertilizer with weed killer, and the y represents bags of fertilizer without weed killer. Well, normally, right, I would shade everything on this side. Actually, let me do this in green. Normally, I would shade everything on this side. But we sort of have a constraint here because this is, a real world problem. And we know that the number of bags of fertilizer cannot be negative. So really, the only thing that should get shaded is everything on this side, but in the first quadrant. So now I'll go back to blue and shade what really should be shaded. So this really should be the solution. Do you guys see why? Because I can't have a negative, I can't have anything over here because that would be, negative bags of fertilizer with weed killer, and I can't have anything down here because that would be negative bags of fertilizer without weed killer. I can't have anything that's negative, so it has to stay positive. So anything in this region right here would be okay, right? That would be the solution. So it looks like in this example, the answer is going to be A. Okay, great. So that was the practice for 3B.